Hi, this is Paul again. I've got another video to show you, and this I'm calling 3D print Duo Phi Vector color sequence for the Icosahedron. I'm showing in front the bronze dodeca with all the vectors sticking out. This is from my previous video. I've decided to make a little toy so that the color of the vectors can be kept in the same sequence, so it's more or less a standard for everybody to work with. So I think I'll better give you a glimpse of the finished toy, and we'll give it a little spin around. Now you can see that I got the vertices, pentagon vertices of the icosa of all different colors. Actually there's a pair, 6 pairs altogether in different colors. So those colors are orange, blue, red, green, cyan. Oh, one more color, a purple. That makes 6. Now the icosa has 20 faces, so I've given them 5 colors. Now in the center of these faces I've shown the triangle vertex of the dodeca, and if you follow them edges you can see how a dodeca goes together. I'll stop in this view because you can see the 5 colors are different colors on the faces, and you can see these 5 colors are on the 5 vertices, triangular vertices of the dodeca. Now if you look at the cyan face and red triangle, when you follow that cyan and red vector through the center to the other side, the color of the face will change to red and the little triangle will change to cyan. Now this applies to the 20 faces. The colors switch around. The opposite colors switch around. Now there's something else I'd like to show you. The duo colors for the dodeca vectors all come from the colored cubes. So I'm going to show you the arrangement. We'll start with the cyan cube. The cube has 4 diagonals. You can see that each diagonal is cyan and it's got another color coming from the 4 remaining colors. Now we'll go to the yellow cube and we have the same type of color arrangement, this time using a yellow vector. Now we'll show the purple cube and it's the same for that one. So now we can show the red cube. So we have 1 color left, so that's going to be the green cube. So now we can show the dodeca with the 5 cubes with all the dodeca vectors. So now you can see it's more complicated than just one cube, X, Y, Z, up, down, left and right. Now if you look at the globe of the world, you've got latitude and longitude. But with this type of geometry, it's a different kettle of fish. We're looking at phi. And just because somebody uses big, long, highfalutin words in 2 dimension, is definitely going to fail to see this wonderful order in 3-dimensional Phi vectors, because this is not a theory, it's reality. Okay, so now I think I'd better show you how I constructed this Duo Phi Vector system. First of all, I'm showing what the hub looks like. Now you can see the hub opens and closes and holds 5 faces as a pentagon, very secure. I'm using a 632 bolt, 1 inch long. Okay, so now I'll show you how this goes together. Now when I put the parts from the 3D printer together, I found the first dozen parts were the hardest to put together. I needed 2 pairs of hands. But as it started taking shape, it got easier. The pieces seemed to fall in the correct places pretty good. Now I'm showing this in these colors, but now we'll go into the full color arrangement. Now you can see this is a nice little toy for the kids, and it also could be the basis of a CPU 3-dimension, because I think we're looking at the processor of life in this beautiful arrangement. Because I put a video a few years back, I called it the DNA Metro of order. The guys in the Mathematicians Forum took a look at it and decided that only a crank would work with trivial geometry that nobody else understands. It looks like the number crunchers can see everything in 2 dimension, by using a couple of equations. My abstract about the Duo Phi Vector system was rejected by a female academic from England. She said, "Thank you very much, but we won't publish this sort of thing." She also thanked me for my interest in science. I guess I can show that this system was used in Stonehenge and by the ancient Egyptians in my last videos. But maybe 3D geometric order is not good enough for today's elite. Now I'm going to show you what came out of my 3D printer. So you can see that the parts came out pretty good. I use a Dremel 3D40 to do the job. I also use Simplified 3D to do my slicing. Now the beauty of this design, you only have to have a one color 3D printer. And the smaller vertices of the dodeca on the icosa faces, I've given them a 2 or 3 degrees taper, and they fit perfect. This design is a very strong design. It's like an eggshell. It's a little bit like Buckminster Fuller's geodesic domes. A lot of people showed a lot of interest in three-dimensional work when Bucky was around. But now everything's gone back to two-dimensional work. There seems to be millions of results about chaos on the internet, but everybody seems to repeat the same thing. I don't see anybody saying that the chaos theory has been solved. They just repeating and saying it will be solved with the big new computers. When springtime comes and you see the trees blossoming and the leaves coming on the trees and the beautiful flowers coming up, how can they call it chaos? And when you see young children with beautiful features and you wonder, how can you call this chaos? Anyways, what can you say? I think it's time that Paul called it a day. So this is Paul saying thank you very much for watching my video.